Hi, welcome everyone. Thanks for coming to this webinar. We're going to be talking today about DDoS attacks, which has been in the news, but we want to share some new information that I think can help you to understand what's changing and how you can address it, maybe some things that you might be overlooking, even if you're already familiar with what a DDoS attack is and how it works. So we're right at the top of the hour, but I'm thinking maybe we'll wait just a little bit more for a couple people to come in. And so while we wait, I'm just kind of curious, geography, where people are dialing in the chat. So maybe in the next 30 seconds, so that we have a better sense of the audience, maybe say what geo you're from or what regions or city, and whether you've experienced a DDoS attack at all or not. That'll give us a better sense of who we're talking to and who's on here, and you'll get sort of better content and things that are tailored to you. But we'll be starting in about 30-ish seconds. I just want to make sure that some people who are straggling on are able to get on. All right, so why don't we go ahead and let's begin. So today I am Tim Fong. Both of us are at Cloudflare, Tim and Junaid, and we're going to be talking about DDoS attacks. And if you've heard of them, or even if you've been under a DDoS attack, I think you'll still learn some new things. So let's see here. Should I do that? Or, there you go. Cool. So what we're going to cover is things are changing in the DDoS world. And so we're going to give you an overview of what are those changes and how those may impact you. Particularly some DDoS continues to be in the news, and we'll kind of look at what are those things behind that. And then a little bit about how you can handle them and things that we do, seeing that Cloudflare sits in front of a bunch of websites and blocks DDoS, and what works and what doesn't. So let me jump to the next slide here. So before I jump into that, I wanted to kind of frame it in terms of the larger context of problems. So Cloudflare sits in front of a bunch of websites and applications, APIs, and we see a number of common problems. And so they're listed here. But what I think is interesting is a DDoS attack actually connects with all of these. So there's the actual DDoS attack, which is the problem, but we also see them as they can be performed by malicious bots, particularly some of the newer ones attacking the application layer. DDoS attacks have also been used in conjunction with a multi-vector attack for data theft. And then the impacts are they affect your site. They can especially affect mobile because of its exposure through APIs. And then when they're successful, they make sites unavailable. And so these are the big 6 sort of primary problems, but DDoS actually touches all 6 of them. So I think that that's something that makes it worth paying attention to. So let's take a look here. So the new DDoS landscape. So I'm going to introduce here Junaid, and he works at Cloudflare, and he works with a lot of both the data and customers that are impacted by DDoS. And he's done a bunch of presentations with other companies to sort of explain to them what's changing in the world of DDoS attacks. So I'm going to turn it over to him, and then throughout this, feel free to start placing questions. We'll field them at the end, or if I see something that's relevant to talk about on a particular slide, I'll chime in. But right now, Junaid, thanks for taking the time to join us. Why don't you pick up from here?
No problem. Thanks for the introduction. So hello, I'm Junaid Ali. I run support operations here at Cloudflare, and a lot of what the focus of what I do is helping customers with DDoS attacks and automating their systems to help them cope when they're under attack as well. So the way I wanted to start and introduce this is this slide here. You can see kind of the peak attacks through March of 2018, and these are kind of the headline figures. So if you'd kind of go into a tech news outlet, you'd probably see a news article saying new giant DDoS attack at 1.7 terabits per second. And presumably close to it, someone wearing a stock image of someone wearing a Guy Fawkes mask and dressed in all black. But what I really want to drill into in this talk is going behind these numbers and analyzing actually what the trends are in these attacks and how, in many cases, the volume of the attack isn't necessarily tied to how powerful it is. So on the slide, I'm not sure if you can see, but in the kind of bottom left-hand corner, you can see kind of it's got a internet connection at 10 gigabits per second for scale, and that's kind of if you were running a web server, you can imagine that you'd put it in a data center and you would have that 10 gigabits per second given to you. And as you can see, as time's gone on, there has been a change in from 2007 when we had an attack being about 240% of that, right up to 2018 where we're now seeing attacks in the terabits per second. And alongside this growth, we can kind of see a change in how these attacks are going. So I just wanted to start off by getting an understanding of where the audience is with this. So I'm going to just set up this poll question, which is about application layer attacks. So I just kind of want to understand how, if you've come under a DDoS attack, or if you have concerns, where do your concerns lie? Is it purely for HTTP, web browser traffic, or is it mail, SMTP, file transfer protocol, or maybe you care about a different protocol? I'm just going to give a little bit of time for you guys to kind of answer that and some votes to come in.
While they're answering, maybe Janae, we can chat a little bit while they talk about this. Why did you want to talk about layer 7 in the context of the growth? So you sort of talked about how the volume has changed. So isn't it about volume, or why are you bringing in the discussion around layer 7 at this point?
So specifically, what I'm trying to get at here is it's not necessarily the size of the pipe which matters. It's more the what someone is doing to congest that. So I mean, if you imagine you go to you're at a restaurant and you want to stop everyone else from ordering. So what you do is you block up the doors and you hire 100 odd people to stand in the restaurant so no one can go in and order. That requires a lot of people, but maybe instead you could get just 20 people to sit in the seats and order the most complicated dish on the menu. So it's kind of this trend, which I'll talk about a lot in this talk, is how attacks are becoming more sophisticated to do a lot more with the network capacity they're using, and not necessarily just just trying to fill up the pipes however they can.
Yeah, and then we'll get to. I think we're almost done with the voting. Yeah, so cool. So I think we can share a little bit of the info here, and then we can kind of continue.
Sounds good. Yeah. So it looks as if we've got 38% of people only care about HTTP or HTTPS, which is, in a lot of cases, this is the application layer which a lot of businesses face. So there's also at 19% SMTP traffic, so mail traffic, 14% some people are putting FTP, and then interestingly at 28%, which is the second highest behind HTTP, HTTPS, is other TCP protocols. So I'm guessing in a lot of cases there people are kind of talking about other protocols like IoT protocols or network sharing protocols and things like that. So I guess we can also talk a little bit more about that through this talk as well. So I'm just going to kick this off with a analysis of the major recent attacks we faced in April 2018, so this month so far. And on the first slide, what I've got here is I'm talking about network layer amplification attacks. And if you're unfamiliar with what network layer amplification attacks are, is in effect they're when you're communicating over the internet, it's commonly done either by TCP or UDP. Every protocol sits on top of this kind of network layer protocol. And one of the things which is important about that is when you're dealing with traffic over UDP, it's possible to spoof who is requesting it. And often over the internet, when you make a response or when you get a response back from a server, it'll be a lot bigger than the request. So as two examples here show, there's DNS amplification, which has been around for a very, very long time. It's a very easy way to get attack capacity. You go and find unprotected, DNS resolvers on the internet, and you can use that to generate a lot of attack capacity. The other way which we saw recently is memcached, and memcached is kind of a caching application for web servers, for servers in general. And when these servers are exposed to the internet, they use UDP, and it's possible to use them to amplify an attack. So someone could be sitting, at their home, and they just want to, get tons of capacity. So they could, say, okay, I am the victim, and I want to, I'm making thousands of requests, whereas in fact, they're the attacker. They spoofed where that response should go back to, and because of that, memcached will receive the response and they'll fire it off back to someone who's a poor victim, and in doing so they'll clog up the network traffic. So DNS amplification, we see a few kind of spikes of that data, in the tens to hundreds of gigabits per second, and then with memcached you can see the kind of spike when this initially occurred, reaching around just under 900 gigabits per second. But we haven't really seen more of that since the attacks have kind of trailed off. The other thing which is important about network layer attacks is at times they get big. So not necessarily talk about amplification attacks here, but one way of doing this is where you have control over, say, a bunch of servers. You've gone out and you've infected them. You can basically get them to clog up the network capacity of a victim, basically. And one of the ways of doing this is a SYN flood. So we talked about UDP. In terms of the TCP protocol, before a network connection can be made, there has to be a handshake, and that's the thing which ultimately kind of limits the effects of in effect the kind of amplification vector. But one of the things you can do with that is you can just send out the first step of that handshake, and you can use that to bombard people with requests and clog up the network traffic. And if you do that enough, you can effectively take them offline. And here again, you can see kind of a SYN flood, this type of attack, which reaches towards about a terabit per second, not quite there. And then the attack kind of trails off. It's not a consistent threat. It's not something we see every day. But when it happens, it's mitigated automatically. And often the only reason people notice them going on is they'll look up at one of the monitors in our office and see, a huge spike in automatic DDoS mitigation volume. So that's kind of the other network layer attack vector we see, and this happens from time to time. In terms of staying on the network layer attack topics, this is kind of spreading these attacks out back to 2017 up to April of this year. And you can see that this is a volume of attacks we see, not necessarily just the traffic. So these attacks usually stay around 300 gigabits per second. And this graph kind of shows, there's times where these have spiked up to being, close, past 700 attacks a day. But often, most of the time, these attacks are relatively few, and they don't really tend to come up a lot nowadays at the network layer. If you are obviously exposing a more vulnerable network, which doesn't have a lot of capacity, you can probably see examples there of where the attacks are kind of more, these are more likely to happen because people know that the network doesn't really have the capacity to deal with them. But from Cloudflare, often what we see is these attacks kind of relatively becoming increasingly rare, I'd say. So with that said, I'm going to move on to application layer attacks. And application layer attacks are interesting because they almost resemble legitimate web requests. So if you imagine the example I used earlier, if you had at a restaurant, hundreds of people clogging the entrances to the restaurant, it's very easy to identify that those people, aren't legitimately there to go and eat. Whereas if you get a small amount of people to go in and order the most complicated thing on the menu, it's quite hard to differentiate them between real customers. And application layer attacks often resemble real web requests. They aren't really when we talk about network layer floods, they're quite blatantly just attempts to flood the capacity of the servers and the network apparatus there. So again, over the past 6 months, we can see the application layer attacks, and we're only here including large attacks. So large attacks are the ones which trigger our automatic mitigation systems and aren't usually the types of slower or the smaller attacks, which are of higher risk to small to medium businesses. So we've kind of left that out of this chart here. And we haven't included data on where a user is able to go into Cloudflare and define whether something is an attack or not based on their own capacity. This is only including very, very large DDoS attacks, but even still, you can see there is a consistent level of them nowadays, and the trend is more towards these types of attacks than actually at the network layer itself. I mean, one of the things which kind of fed into this for Cloudflare was we did towards last year rather, we basically announced kind of unmetered DDoS mitigation for network layer traffic. And as this happened, you can see attackers being more sophisticated and wanting to move up the network stack as well. So I'm going to talk a little bit about how Cloudflare deals with these attacks. And often when you go onto a CDN or DDoS mitigation services website like ours, you'll see this kind of map come up of the data centers around the world. We're quite lucky in the fact that of all the CDNs in the world, we have the most presence in internet exchanges, and that's kind of where most of our deployments are. We will basically build up some servers, and what we do is we ship them out around the world to internet exchanges, and that's where we kind of do DDoS mitigation. And the advantage there really is we're very, very close to the source of an attack. We're also very close to legitimate users, and that gives us the added benefit of adding performance benefits. But obviously this talk here is about the security side. And in effect, we have this very, very large global presence, and we're able to deploy these in a very scalable way. And the other thing which is interesting about our network is it is an Anycast network. So we have over 15 terabits of capacity, but the other thing which it quite differentiates us as a network is the fact that our network is designed to do HTTP over Anycast instead of just doing, so if you were to go to, say, Netflix and you wanted to watch a movie, what would happen is you would go to their website and there would be a bit of JavaScript on the page, and that JavaScript would basically route you to a close Netflix data center, a small deployment. And the way it would do that is it would tell you the individual IP address over unicast. That's a one-to-one relationship, one visitor to one data center. The same thing happens kind of with Google when you go and query google.com. Google uses DNS to kind of steer where that response should go. So it'll give you a different IP address depending on your location. I'll talk a little bit more about this in a second, but basically the way Cloudflare works is our network, our IP addresses map onto our entire global network. And what this means is it's a lot easier for us to petition DDoS attacks. It means that no one is able to target an individual data center. The attack is automatically distributed across the network using BGP, the routing protocol of the internet. And we don't have to wait for things like DNS cache TTLs to expire, so the DNS kind of cache expiration to expire before we can relocate visitors. So in the chart, you can see an example there of where we turned up a data center back for Italy, and Italian traffic immediately shifted from Frankfurt back to Milan. And we basically have that turnkey ability to reroute traffic as we see fit. Because we have this big network, we're able to directly interconnect with lots and lots of different consumer ISPs. This obviously has performance benefits, but the main benefit from DDoS protection perspective is that we have a very, very close link between the attacker and our network. And the end result for a lot of DDoS mitigation providers is if they're routing traffic over an intermediary, and if the attack actually gets pretty big, they can end up taking the intermediary down as basically collateral damage across the internet. But as we often have a direct connection to the attacker, that's not really a risk for us. And then alongside this, we can use this big network to do other intelligent things in terms of routing. So tiered caching is one example. If you have a cached asset in a data center, which is closer to in one of our data centers, which is closer to your data center, we can go and look that up before we have to go back to your data center. And often caching is a useful tool in mitigating application layer attacks as well. The other side of this is when we talk about rate limiting, as we can guarantee that someone can't override our routing behavior, and we know that traffic from a given consumer ISP will always reach this given data center, we can therefore say, and we can therefore guarantee that we can do rate limiting within a data center itself, and we don't have to necessarily share that data across every single data center. So it makes it very, very easy for us to scale rate limiting, especially when we're talking about very, very big DDoS attacks. The other useful feature as well is Argo Tunnel, which ties into smart routing. So often if you have a server and you don't want to expose it on the internet at all, Argo Tunnel is basically a bit of software you can set up. And what happens with Argo Tunnel is we basically will make a direct connection to your appliance without exposing an IP address. We kind of hole punch our way into the server you're talking about, and by doing that, we're able to hide your presence, hide where your server is, and mean that attackers can't target it directly. And your server's effectively just taken off from the internet and just routes through Cloudflare. So the example I was talking about earlier in terms of Anycast IPs is here I'm querying my own domain using a DNS lookup tool called Dig, and when I run this query anywhere in the world, I will always get these 5 DNS records returned. The IP addresses remain the same because we route traffic geographically using BGP, the routing protocol of the internet. We don't route traffic using DNS, which seems quite in principle, the right thing to do, but actually in terms of networks which use Anycast over HTTP, we are the biggest network in terms of domains, in terms of traffic as well, doing HTTP, TCP traffic over Anycast. So the other example I'd point to as well is when we're talking about Google.com here. So when I run queries for Google.com around the world, I get a different IP address, and that's to steer traffic to local data centers. And the way that works is the initial connection, or rather the DNS lookup. The DNS server uses Anycast because DNS is a UDP protocol. There's an Anycast lookup for the Google DNS servers, but they return individual unicast IPs for the HTTP connection. Whereas for Cloudflare, the DNS is over Anycast and the HTTP connection is over Anycast. And there is no way an attacker can override that routing behavior without causing a lot of collateral damage. And if they were able to kind of perform any form of root leak. It's something which is very easily controlled. We recently wrote a blog post about root leaks on the Cloudflare blog, which if you're more interested into how BGP works, that can provide some useful guidance, but I won't talk too much about that here. But the end summary is an attacker effectively has no control over where they're routed. We retain control of that. There are other benefits of doing HTTP over Anycast. So as we've already covered, when we're talking about unicast traffic, the steering is done over DNS. The traffic control can be bypassed because you have the IP addresses, the individual unicast IPs of the servers. You need to wait for failover to happen in the DNS cache before you can actually reroute traffic. And when you want to actually turn off a data center, for upgrades or whatever the reason is, this can be quite critical because there are an awful lot of ISPs, consumer ISPs on the internet, which will just have their own DNS resolvers, and as a result, will just not respect DNS cache expiry times. But for us, we do this as we're an Anycast network. The geo-routing is done using the shortest path to a given IP. Generally, this correlates to geographically the closest IP, but it's often in essence actually means it's closest over the path followed on the internet. We have immediate failover, so when we want to change traffic around how it's steered, we can do that immediately. And DDoS attacks are automatically repartitioned across our network. So a DDoS attacker, where they've got a ton of botnets or tons of computers hijacked, they actually have no control over which of our data centers they attack. That's all. That routing behavior is effectively controlled by us. So here's a crude example. If you're, say, in Exeter in England and you want to connect to a Cloudflare site, you have no control over where your traffic's routed. It could be routed to London if that's the shortest path between your ISP. If we wanted to steer that traffic differently, so we wanted traffic to hit Manchester instead, we have that ability as well. And that's, again, controlled by us using our BGP routes. So I think it's time for another quick poll. I'm curious about where you stand on this topic, really. So I think we should be able to fire off a new poll, which is talking about Anycast versus unicast and DDoS attacks. I mean, do any of you have a preference either way on this, or where do you kind of feel around this topic before you kind of came into this webinar?
Yeah, I think the goal is, I find that we often talk a lot about Anycast, and there's a lot of detail, but I'm really curious if people if it's resonating and they're seeing there is a difference or not, and this is valuable for us to understand. It's either there is an alternative where they think unicast in the end still doesn't make any difference, or it's the same or better, or we're not communicating sort of what the difference is between an Anycast and unicast and why it's relevant for DDoS. So I'd love to kind of hear, just sort of very simple, do you think it makes a difference or do you not? Because I think the level up of everything, if I had to, was, when you have a single IP address that comes out and everything gets dispersed. So effectively, if you have a bunch of data centers and they all have the same IP address, that traffic's going to go and be dispersed across all those data centers. And that's sort of like the primary way to stop the DDoS from sort of exceeding capacity at any single location.
Yeah, I agree. It's kind of one of those Anycast versus unicast. It's kind of one of the nitty-gritty network topics, which often people get confused over and don't really want to look into, but it's kind of more relevant for networks like us, which are operating at scale. And then the other thing which often ties into it is there are DDoS providers out there who just run very, very small deployments of a lot of data centers. For them, the difference is potentially marginal, whereas for us, we have data centers all around the world, all of different capacity. So yeah, it's an interesting question, I guess.
Do you think Anycast matters more for certain types of DDoS attacks? Because we talked about there's an application and then there's a network. Do you think it matters at where in OSI the attack is taking place, or even the application where Anycast matters more or less?
Yes, I think in essence the main difference almost comes down to the fact that it's actually with application layer attacks, you almost get a little bit more bang for your buck when you're doing the attack. It's you can achieve a lot more damage with less capacity. So in that case, if your filtering mechanism for your application layers over unicast, potentially you could argue the impact would be less severe. But particularly for network layer attacks, Anycast does provide us a very good benefit. The other thing as well, when we talk about application layer attacks, is the benefit as well when we're talking about Anycast is that we're able to guarantee how internet traffic is routed. So it means when we are doing filtering behavior, it's a lot more easier to control the specifics of how we know a given attack is coming from a given or if a attack is coming from a given ISP, it is always going to hit a particular data center. And given that we have that knowledge, it makes things a lot more easier to kind of filter those attacks out. I think we should skip forward from this slide, but it looks at the poll at the moment. It's kind of 65 to 35%. So yes has the edge here, 65 to 35. But yeah, I'd be curious if anyone has any opinions on this, or if anyone has any questions, please do leave them in so we can talk about this a little bit more towards the end. Hello?
Yep. I think it's you now.
Oh, sorry. I was just... there we are. My screen froze there, so for a second I was hoping I wasn't kicked out of the webinar there. So I'm going to move on now and talk a little bit about how we analyze these DDoS attacks and how we actually filter between attacks and how we block them out. And this is kind of the second part. So if you imagine we have these servers which we deploy globally around the world, and they have some filtering logic in. It's almost how we analyze that data and how we work out when an attack is coming in, how we correlate that data, and how we use that data to basically mitigate an attack. And in part, how you got to see those charts towards the start. So our edge networks and the servers we deploy in internet exchanges around the world, and at times we'll deploy them in individual ISPs data centers, but mostly in internet exchanges, public internet exchanges around the world. Those data centers will produce a lot of logs. We're talking daily in the petabyte range. And these logs are basically sent to large-scale data processing warehouses, which are pretty large facilities we have, which we kind of refer to as our core network. We obviously definitely don't have the capacity to store all the the data which was particularly sent from our edge networks is normally traffic which has anomalies or traffic which contains attacks, and even in those cases we only are able basically to send a few of the headers of those requests, and we can't even store those because of the amount of capacity it would take, because Cloudflare as a network sees 10% of internet traffic. So we have to very quickly analyze that data and then aggregate it so we can get rid of it as quickly as possible. So in this sense, the way it kind of works is when a request will be sent in from a edge data center, it goes through a kind of compression format, and it goes through a standardized log format, and it comes into a data center. And when it's received into that data center, it goes effectively through a message queue. And what this message queue does is it will have various services reading off that to analyze the data and determine whether something is an attack, whether maybe there's been an ISP's misrouted network traffic, maybe if we're talking about our enterprise customers who actually want to receive a copy of this log data, whether this data needs to be forwarded directly to them as well. And in this sense, the way we do that is we have this message queue, lots of microservices processing data off this, typically written in Go, and they're processed asynchronously. So one particular microservice doing a hefty processing job can't go ahead and block the entire queue.
Hey, Junaid, I think we're coming on time, so I want us to maybe one of the things that people are would be interested in is sort of like you talk about the future and the change of it with a long tail. I think this is an interesting spot to kind of jump in there and do it.
Yeah.
Because of the data that you talked about, we have a lot of visibility into who's attacked and the nature of those attacks. Elaborate on that.
Yes. So I was talking recently to a friend of mine who's in the digital agency world. He was telling me that DDoS attacks are often actually becoming between small and medium-sized businesses. Often they're becoming basically a tool. If you can knock a florist offline, then in essence you can potentially pick up their business if it's close to Valentine's Day, for example. And so, in essence, there's lots of other reasons why people are running attacks. In a lot of cases, a kid in their bedroom will see a YouTube video on how to do this, or someone else will just see a pay now button on a website to launch a DDoS attack and pay $5 and it'll fire off a DDoS. And what I really want to talk about is the long tail of DDoS mitigation. So it used to be the case if you're launching a very, very big network layer attack, it used to be somewhat costly to do that. Now the price has gone down significantly. You only need to hijack about 2,000 computers to really launch a kind of sizable network layer attack. And if we're talking about application layer traffic, when you think, a small business's e-commerce site or even a fairly large national retailer, their site would only be able to handle, if they're a small business, a couple dozen requests at a time. If they're a particularly large business, maybe a few hundred, maybe a few thousand requests simultaneously. And in that sense, it's a lot easier to just automate that process of repeatedly making complicated HTTP requests and using that to either extort money or some other form of benefit, if there is any benefit at all, to basically take a site offline. And as the top Alexa 1000 sites will likely have the capacity to deal with this. But if you're talking about, the rest of the Alexa top 1 million, chances are they will fall into a bucket where they won't have the capacity to deal with an awful lot of requests. So I'll move forward a bit quickly. With application layer attacks, it is easier than ever to run a DDoS attack. And when I was giving this talk in New Zealand a month or two ago, the comment came up when I made the comment of 2,000 computers all you need to hijack, and someone raised up their hand and said, we get 20 times the capacity of the average of 4.7 megabits per second. So again, around the world, it's depending on who you're able to hijack, it can become a lot easier to launch these attacks. Breached IoT devices, another attack we saw recently with the Mirai botnet. Again, in that case, the attackers were able to effectively launch DDoS attacks because those webcams were set up on network connections designed to stream video. And as a result, they were basically able to use that to launch DDoS attacks, again, of sizable capacity. And the application layer attacks are very, very easy to automate. It is also very efficient because there's this asymmetry when we're talking about an attacker and the victim. the victim will often have a lot less capacity. And the other thing which is critical is it is a lot harder to generate a response to a legitimate request than it is to send a legitimate request. And when we talk about that in terms of an attack, you can exploit that imbalance because it's very, very easy to send off a bunch of junk requests, and it's very, very hard to respond to those effectively. And again, another trend we're seeing in terms of this is effectively, I say layer 6 here, although a TLS doesn't technically lie in layer 6. But in this example, again, people are able to pick the worst cryptographic ciphers when you're talking about, say, a HTTPS connection, and use that to increase damage. So I think I've covered this quite extensively, but again, to recap, it's when we're talking about small websites are easier to attack, and therefore attacks are more likely to choose them. Most apps can only handle a few hundred clients. They're easy to launch an attack. It's harder to differentiate junk traffic from the real traffic. And then again, we see false DDoS threats being used to extort money, and we have a lot of content about that on our blog. So these application layer attack vectors will typically work against any type of layer 7 application, whether we're talking about email, whether we're talking about sharing protocols, FTP, HTTP, etc. So it's important to protect your origin web server, however you're routing traffic. If you use service like Cloudflare, you can use services like Argo Tunnel to hide the IP address of your web server. We also have a new product called Spectrum, which allows you to proxy TCP traffic through us, and that helps ensure that you aren't revealing the attack or the IP address that can be publicly attacked. And you can also use us to mitigate those particularly bad network layer attacks, and also some of the application layer attacks as well. In terms of HTTP traffic as well, cache aggressively, use Cloudflare to quote unquote cache dynamic content. So for example, cache the all HTML, but the moment a request is sent through with something added to a shopping basket and therefore a cookie is set, bypass the cache and go through to basically go straight through into to the origin, as that request is dynamic. You can use that for fine-grained control with workers, and we also have functionality for custom cache keys as well. And introduce some form of rate limiting. There's no legitimate reason for someone to be sending you from one IP address 100 HTTP requests a second. Use enable rate limiting if you have the option, either at a service like Cloudflare at Edge, or even at your origin web server. And in that case, you can prevent excess HTTP requests. Obviously, doing it at your provider for DDoS mitigation makes things a lot more easier on that perspective. Moving forward, I'll go straight into questions here, just to leave some time in case anyone has any particular questions. So anything you want to follow up with that, Tim? Or?
Cool, thanks, Junaid. I think we're hitting up on time. So I don't see any questions being added here, but there is one that has come up in the past whenever we've talked about. There's a sort of a laundry list of things that you've added. We went through it very quickly. We talked about TCP, we talked about other protocols, hiding the IP address, and then various forms of threshold-based things. What are things that people overlook? Like it seems like you talked about Anycast at the beginning. You frame it, hey, as long as you have Anycast, you'll be able to disperse it. But really, there's different layers and nuances to it. What's something that people overlook but really should think about as it's an open vector and it's just ready to be exploited?
Yeah, so in terms of hiding, when you sign up for a Cloudflare or a service like Cloudflare, we will typically, issue you a new set of IP addresses with your Cloudflare account, and then we proxy traffic from when a request comes to us back to your origin web server. One of the things we are quite diligent at, especially when someone signs up for us and is under attack, is to make sure they rotate their IP addresses or use a service like Cloudflare Argo Tunnel to basically hide where their service is running from online. That's very critical, so no one can go ahead and look up through historical data and see how to bypass your traffic. In terms of the other things, often at Cloudflare, when we talk about application layer attacks, it's very important to go ahead and, if you are worried about application layer attacks, to turn on, caching and some form of rate limiting. And the reason why is often if your origin is quite weak and isn't capable of being able to cope with thousands and thousands of HTTP requests, then giving us the ability to or rather you defining how much legitimate HTTP traffic you expect a visitor to make, that can help make things a lot easier for you as well when mitigating a DDoS attack. So
thanks, Junaid. I think we're going to start to wrap up here. To summarize, if there are other questions, I'm glad to sort of sit down and answer. I think some of the things that I take away often from talking with customers is there's an unexpected exposure. So it could be if you're running any other service other than HTTP, there's some exposure. If you have just HTTP, but even something as an accident in terms of how you re-IP, or if you didn't re-IP or it's sitting somewhere in some stale DNS cache, your IP address is open. In fact, it could just be scanned. And so there are tools which people can use to scan your space and still attack you if you don't have a way to lock that down. And then I think the details around, as we saw the long tail of HTTP attacks, I think they're growing. And so being able to be sophisticated and granular, and how do you identify what a volumetric attack is that's not in the terabits, but it might be in the 50 to 100 requests per second. I think that requires some sort of more nuance. So if people are kind of curious, how do they explore it further, feel free to contact us. There's a ton of links that you can go to right in the thingy, the registration, for you to read up on the details that we talked about, as well as to get into contact with us directly.
Yes, definitely.
So thanks everyone for joining. Thanks, Junaid, for spending time with us and sharing some interesting info. Thanks everyone for joining, and hope to hear from many of you soon. Bye now.
Absolutely. See you guys later. Bye.